afternoon, everyone. Well, by now you know the reason why I am starting the class 1 minute earlier because those who come before time, I really want to honor them and take their name. Those who are watching the recording, they can skip the first minute or so. Visalakshi Chiller, Shikha Kotwal, Yash Jolly, Tanisha Matthew, Khwaish Jaswal, Sana Srivastav, Monia Mehta, Isha Dhal, Arnav Verma, Ansh Bhatia, Ritvik Bhatia, Mudit. Welcome, good afternoon. The count is showing less, but actually there are more people because I have already taken names of few people. So today's agenda, and you might be seeing some pulley kind of thing also, we will be moving to that too. Today's agenda is the motion of connected bodies in the vertical direction. So towards the end of the previous class, which happened long, Rudra Chaudhary, welcome, long time back, which happened and which could not take place due to some reason or the other. And last Saturday, the class could not take place because the sound issues were there. We talked about a situation where blocks were being pulled in the vertical direction. And I showed that to you, and we started with a misconcept, and it doesn't actually sounds like a misconcept, that if you pull something up, if you pull some mass up, if you pull a mass, any block or anything up, it moves up, it moves up. Very puzzling. That's a misconcept. I thought that's a concept, but no, we saw it that when you pull a mass up, it doesn't necessarily move up. Let me get those blocks once again, and let me pick up things which are little manageable. And whenever I'll do activities, remind me to increase the size of the camera so that you have a better look. Okay, so, and now you can see this pulley much better, है ना? We will be talking about those motion of connected bodies over a pulley today. So this is the block, and I am saying that I am pulling it up. Now, is it going up? It's not going up. Now, if you say, sir, you are not pulling it up, you are just playing around with our emotions, you are not pulling it up, you are just leaving it like this, then let me tell you what happens if I don't pull it up. If I don't apply an upward force, this is what happens. It is staying here because I am applying an upward force. And you can understand that. I could have put this force from this side. I could have pushed it up like this. Only then it will stay here. If I am not pulling it up, this is what will happen. It drops. Now, a body being pulled up, you are pulling it up, might be at rest. Please continue to put some comments, even though I'm bad in responding to all the comments, but it becomes more lively. So keep putting some comments or the other. So first thing, even when you are pulling a thing up, it might be at rest. But then come to the second part. I am pulling it up, but the block is going down. Now somebody will say, sir, क्या बात कर रहे हो? नीचे धक्का खुद दे रहे हो, फिर कह रहे हो हम तो ऊपर खींच रहे हैं. If I am not pulling, if I don't apply any force, look carefully, this is what happens. And if it is going down like this, I am stopping it from falling. It is going down, but I am stopping it from falling. So I am applying an upward force. And even though I am applying an upward force, still, let me come back to this. Even when I'm applying an upward force, the block might move up, the block might move down, the block might remain at rest. Have I been able to show you this misconception? that if you apply an upward force, the block might be going down, the block might be going up, the block might be at rest. Very good, Mudit. Very good. So the key word is not which side you are pulling. Which say, are you pulling up or pushing down or down? That's not the key thing. What is the key thing? Key is, this is not the key thing. The key is in which direction is the net external force. This is the key. So when you are applying some force upward, that is not the only force. Let's draw all the forces acting on it. And what do we call it? Vinita Sharma, what is nice? Nice. You have understood. You mean to say you understood. And what do we call this thing when we draw all the forces acting on it? What do we call it? We call it free body diagram. So you are applying a force upward, but there is a downward force also, which we call its weight mg. And now you have to see if P is more than mg, then the body will be accelerated up. Good afternoon, Vinita Sharma. Coming late, I can't respond so much, but still I am responding to you. P is greater than mg. It will, this is called free body diagram. Very good, Vijalakshi. And if P is more than mg, it will be accelerated up. So let me write these conditions. P greater than mg, the body will be accelerated up. If P is less than mg, means mg is more, then acceleration will be down. And if P is equal to mg, then there is no acceleration. And no acceleration means if it was at rest, it will remain at rest. If it was moving with constant speed, it keeps moving with constant speed. All these three cases, you see that key is this. Which side is the net external force? So if you have understood this, and remembering what we did earlier, remembering that what we did, net force equal to ma. So if there is a net force on a body, it will have some acceleration. On the contrary, if you see that a body having mass has acceleration, then the forces acting on the two sides, it is of 11. Yes, Vinita Sharma, I am seeing your name for the first time. But these classes, we have been conducting these classes for a long time now. Well, for those who are new like Vinita Sharma, this is a course from 11th, but we have been doing it in a way that mathematics does not become a stumbling block. I have been teaching this course for a few weeks now, and we have been doing it in a way that those who feel they are bad in maths, I'm not saying they are bad in maths, but those who feel that they are bad in maths, especially there are some people in medical sections who feel math is not their strong point. They, what about others? Vinita is not able to hear voice. What about others? Please confirm. Are you able to hear me? Because voice was an issue in the previous class, not this class. Vinita Sharma says no sound. Oh, don't tell me, because the class on Saturday could not be held because of the sound issue. And I thought everything is fine now. Will others please comment? If the sound is okay, then I ask Vinita Sharma. Udbhav Yadav, what is yes? What does yes mean? Oh, Arna Verma says sound is okay. Isha and Udbhav, will you please say, is the sound okay? Because in that case, दबी दबी सी आ रही है. Sir, we can hear. Use earplugs. Sir, voice is lower than usual. Okay, okay, okay. Another thing, little bit my throat is down, but you could have told me that. Sir, it's low. I'll try to speak louder. Uh, yeah, and Rudra Chaudhary's advice, Vinita, you can listen to that advice. Use earplugs. It might make things better. Sir, sahi hai sound. Okay, okay, okay. Okay, so, low. Okay, so Vinita, put on the earplugs and I will try to speak little louder. And thank you for bringing this to my notice. I will speak little bit louder now. Okay, so if you have, this is the concept we are going to continue even in vertical direction, that if there is a mass and that mass is getting accelerated, then the forces on two sides of it are not going to be equal. Because if they are equal, then in that case, net force should be zero, A must be zero. So if you have A, if any mass has acceleration, then pakka hai, the forces on two sides of that mass cannot be seen. So if you have net force, definitely there will be acceleration. If a mass has acceleration, definitely there will be a net force, and which means that forces on two sides are not going to be equal. Now let us utilize to do some numericals which people who are well educated, have studied in good coaching institutes, they start doing it. Let's see with this much of knowledge, and remember, I'm repeating it, this course is not math dependent. This course is quite independent of math. Those who have been attending all the classes, they know it, how little math we use. Very, very little math we use. Okay, so let's have a question now and let's see how many of you are able to do it. Okay, we will discuss it as we go. There is one block, let's say 3 kg, and there is another block of, let's say, 2 kg, and the 3 kg block is being pulled by say 100 newton. 100 newton. Now remember, if this string is massless, then T at every point will be same, and I can write it like this. All over this string, the tension value of the tension will be same. I want to find out how much is the tension in the string, and obviously one of the things that we always are interested in knowing is what is the acceleration of the system. So remember the full method that we used to follow, and then we moved on to shortcut. The full method was draw free body diagram. So if you have two masses, there will be two. Write force equations. Write force equations. So if you have two free body diagrams, from both of them, writing net force equal, this is what it means, net force equal to ma. So you will get two equations and then solve the equations. This is the full method of dealing with motion of connected bodies. But then there was a shortcut. And what was the shortcut? First step, find A by using this net external force upon total mass of the system. And then to find T, draw FBD, free body diagram of appropriate body. Of appropriate body means whichever is convenient, whichever makes your life easy. Mudit has already given the answer also. So let's see how much is A. Now, if you look at, let me change the color. If you look at this entire system, then there is one force is 100 Newton acting upward, and there is another force which is acting downwards. And what is that? 3 kg plus 2 kg. So there is a 5 kg multiplied by g, that much force is downward. So if you see the entire system, then 3 plus 2 kg, there is a 100 Newton force acting on it like this, and 5 into g is acting downwards. So A will be 100 minus 50 upon 3 plus 2. So it is a 10 meter per second square as given by, Are Mudit, you were giving an answer and now you have removed your comment. So this is the acceleration. Now you will say, why did you subtract 100 minus 5g? Why didn't you do 5g minus 100? You can do whichever you feel like. You will always get the correct answer. Say for example, had I said 5g minus 100, which means my 5G is positive minus 100. So this direction is positive, this is negative. Then I would have got a negative answer, minus 10, which means this force is not greater than this, rather it is the other. That 100 Newton is more than 5G. My advice to you would be, go by common sense. Is 100 more or is 5G more? And if you can see it that 100 is more than 5G, then why to get into confusion? So Mudit, I think you're. I'm wondering why Mudit removed his comment. So this 100, if you can see the common sense, if you can see that 100 is more than 5G, then you know that acceleration is upwards. Then why not straight away go for that value? It is only when there are variables used in question that 100 is not given, P1 is given, 5G is not given, M1 plus M2G is given, then only you need to worry about like is that greater or is this greater. But now with numbers you know it. So why do you get confused? So A is a 10 and it is upwards. A is a 10 and because the value is plus, it is upwards. Okay? Acha, acha, acha. I am okay. Now let's find T. So I will wait for a moment because I want this answer to come from you. I want this T. Should I draw free body diagram of 3 kg or should I draw free body diagram of 2 kg? First listen carefully before you make a comment. Which one is correct? I am asking you one thing. Which one is correct? Should I draw a free body diagram of 3 kg or should I draw free body diagram of 2 kg? Which one is correct? I will wait. I know there is a few little lag in YouTube. I will wait, but I want to see your comments. Udva says 2 kg. Listen to my comment carefully. Which one is correct? Should I take 2 kg or should I take the free body diagram of 3 kg? Udbhav wrote 2 kg and then deleted the message. I will request YouTube not to allow deleting the message. If you have said something, okay, you can put another comment. Okay, Udbhav again says 2 kg. Ansh Bhatia says 2 kg. I want to listen to other comments also because there are more people. Vijalakshi says, I think 2 kg. Ritvik Bhatia says 2 kg. I'm looking for more answers. Arnav also says 2 kg. Okay, so it means my English is quite poor because I could not communicate to you one thing. Sanna also says 2 kg. Rudra says, sir, I think it doesn't matter. Well, Rudra has got the correct answer, but others have given me the answer. Which one should I opt for? I said, which one is correct? Both are correct. Correct. The Monia Mehta says we can take both, but 2 kg. Very good. Monia, that's the complete answer. Rudra says it doesn't matter. Monia says it doesn't matter, but 2 kg would be easier. By taking 2 kg, we will get the correct answer in both. We will get the correct answer in both. Now let us see. If you draw the free body diagram of 2 kg, then there is a T here and 2g here. And the equation is T minus 2g is equal to 2 into A. But if you draw the free body diagram of 3 kg, then you have P equal to 100 newtons here. And here you have T and you have 3 into G. And the equation is 100 minus T minus 3 into G is equal to 3 into A. Now you solve these two and see which one is giving you the correct answer. Which one is giving you the correct answer? If both of them are giving the same answer, then Rudra, Monia, you are right. Otherwise, everybody else is right. Does it matter? Does it not matter? We need to check. find the answer using both. See this one. How much is the answer using this one? T is 20 plus 20 equal to 40 Newton. And here it is 100 minus T, 100 minus T minus 30 equal to 30. So it is 100 minus T is equal to 60. So T is equal to 40 Newton. It does not matter which one do you take, but then you see which one is more convenient, which one is little bit faster, this one. Now what if we are having three masses? Let's do that. Say this is, say, 5 kg, then there is 2 kg, and there is one with 3 kg. So if you pull it, let's say, by some T equal to 200 Newton, then see, if this system is getting accelerated, then you know that tension here and tension here cannot be same, because there is a mass in between. And if this system is getting accelerated, T1 and T2 cannot be same. So I'm taking this as T1, this as T2. And you have to find out the value of T1. Obviously, you have to find acceleration A also, but you have to find out the value of tension T1. All those who are Mudit bhai to 12th D ka hai ya F. Mudit is in 11th, not in 12th. And Vinita, you are new to me. All other names are familiar to me now. Don't delete messages. Vinita, it's okay. If little bit of fun is going on, I have absolutely no issue. Feel free. If I feel offended or if I feel very much disturbed, I'll let you know. Otherwise, feel okay. That's perfectly fine. Okay, Visalakshi Chiller has got the answer 40 Newton. And I am slow, she's fast. Let me also catch up. A is equal to 5 plus 2 plus 3. That is the total mass. And the force 200 minus, I can add up all these together and then multiply by G. The weights of all these. So how much it is? 100 upon 10 meter per second square. Do let me know. And if you are doing some calculations, keep putting them as comments. Yeah, good that there is not a huge crowd in the class today, but those who are there are genuinely interested. Those who came only for just to roam around, by the time the topic becomes involved. Sir, earphone से भी problem आ रही है. Vinita, increase the volume of your system. T2 is 16. Achha, you have found T2 also. But with that we'll see. Let's see. Okay. A is coming out to be 10. This is 200. This is 100 upon 10. So this is 10 meter per second square. Now listen to my question carefully. To find T1, which free body diagram is correct? FBD off. Now I'm giving you option 5 kg, 2 kg to find T1, or 2 plus 3 kg. Now listen, already we have talked about one thing, all are correct. Which one should I opt for? Monia Mehta says A is 20. Have I made some mistake? Monia Mehta, kindly check your answer. 200, this is 10. 10 into 10, 100. 200 minus 100 is 100. 100 upon 10 is 10. So A is correct. Beta, don't delete comments. It seems as if you hate mistakes. Mistakes are not, they are welcome. Perfectly fine. शायद से आपके mic fit नहीं है अच्छे से. Today might be so, but this is the same system. I don't know. Saturday there was no class at all, and today many of you are. Yeah, today my throat is little bit choked, but not that much choked. If there is some sound problem, even after increasing the volume of your device, then please download Dolby Atmos app. Priyanshu, very good. Mudit has given the answer. So it seems only Priyanshu and Aditya Kumar Singh are interested in answering what I am asking. Others are interested in solving the problem. Both are all right. I have absolutely no problem. Okay, to find T1, this is one approach that we took in motion of connected bodies in horizontal direction. Treat this entire thing as one mass. And so what I have is, I have a block of 2 plus 3. Above it there is T1 and down there is 2 plus 3 into G. That makes the situation very simple. T1 minus 50, 5G 50 is equal to 5 into A. And so T1 is coming out to be 100 Newton. Did someone get this 100 Newton? 50, 60. Achha, that 60 was this. Have I committed some mistake? T1 minus 5G, which is 50, is equal to M into A, and A was 10, so 50. This is coming out to be 100. Udbhav, will you please check who is wrong? Who has committed a silly mistake, you or me? But don't delete your messages. You put a message and then you delete it. No, don't be shy of your mistakes. You tried something and that's good enough. Nay, Rudra Chaudhary, what is yes? You need to be little bit more specific. What is your answer? Share that. Visa Lakshi says T1 is 100. Rudra says I got it as 100. What about Udbhav? Okay. No problem, Udbhav. But don't delete your comments. Don't delete your comments. That's okay. Perfectly welcome. Perfectly welcome. Okay, to find T2, I have an option. To find T2, I have a similar option. I can make a free body diagram of 5 plus 2, having P this side, having 7G and T2 this side, or I have an option of 3 kg having T2 this side and 3G this side. As we have seen, both will give us the same answer. And you are welcome to share that answer if you have found it out. I will use this one because this is easier for me. So T2, I'm sure it's easier for you also. T2 minus 3G is equal to 3 into M into A. So T2 is coming out to be 60 Newton and somebody gave that answer already. I think Visalakshi gave that answer that T2 is 60. Good. So let me modify this question little bit. Just a little bit. Let me modify this question just a little bit. Values will not change. There is a 5 kg block. There is a force of 100 Newton. Sounds very familiar. There is a block of 3 kg. Sounds very familiar. And they are joined together by a string having mass. A string having mass. Now, a string is having mass, and let's say that M is a 2 kg. Can you see that these two questions are identical? The total mass of the system is the same. You see 5 kg, 3 kg, and this one has a 2 kg, 2 kg mass of this string. These two questions are exact. Oh, sorry. This was not 100. This was 200. Yeah. So 200. Now these are exactly identical. Do you see that? But what is the difference? See, so far I have not taught you math. If you notice it, I have not taught you vectors. I have not taught you differentiation. I have not taught you integration. I have not taught you so many things in math. Dimensions and all those kind of things I haven't taught you. But still I see that there are enough number of people who are understanding everything. I want to communicate to you one thing, and many of you might be opting for medical section. Learning physics is not math dependent. Yes, if your math is good, you can, that's a language of physics and you can do lot of things. But then you need not be scared if your math is weak or if you are not interested much in math. You don't need that much of math. Coming back to this question, what is the difference? Very good, Mudit, very good. T at different point of the string will be different, because if you consider any point, you will see that on the two sides of it, because the system is getting accelerated, A is the same that we had earlier. A will be 10. Total mass is same. This is 200 Newton. A is going to be 10 meter per second square upwards. Okay. If you take any part of the string, then that mass is getting accelerated in the upward direction. That part, that mass is getting accelerated in the upward direction, and so the forces on the two sides of that mass cannot be seen. And so you will find at different points of the string the tension is different. So what you have to do now is you have to tell the tension in the middle point Tm, you have to tell the tension at the highest point Th, and you have to tell the tension at the lowest point TL. You have to find tension at these 3 points. What do? First step is something that you are already well versed with. 5 plus 2 plus 3. 200 minus 5 plus 2 plus 3 into G, and this is going to give you 10. This part is understandable. I hope so. This part is understandable. Now, to find TH, can you tell me here what is similar to finding TH? Look at this previous question and tell me what is similar to finding TH. Look at it. Finding TH is the same as finding something in the previous question. What is that? Finding TH here, the highest tension at the highest point, is the same as finding something in this question. What is that? I know there is a lag. There is a lag in YouTube. I will wait for that much of time, but I really want to see your comments. In this question, the string has tension. You find TH here. It is exactly the same as you would have found something in this question. Anshul says T1, because the point where you had T1, below that you had a 5 kg block. Good, Priyanshu, Mudit, Isha, Sanna. All of them gave the answer nearly at the same time, and all are giving the correct answer. Do you see that? This was a massless string. So this string having 2 kg block, this string is connected to this 5 kg block with a massless string in which we found the tension here T1. See, this 2 kg block could have been that string of 2 kg. Sir, we can replace 2 kg string. Yes. Vijalakshi, very good. This 2 kg block could have been a rope of 2 kg. And so the highest point of that rope, of that string, is connected to 5 kg with a massless string. Obviously, no string there, but connected to it. So that part we expanded by putting a massless string, and we found a T1. Likewise, T2 and TL are exactly identical. Yes. Vijalakshi, very good. Finding TL here in this case and finding T2 here is exactly the same. If you are understanding this, then can you tell me how should I draw the free body diagram of it so that finding Tm becomes easy for me? So that finding Tm becomes easy for me. What should I do? What kind of block should I make that I can find Tm easily? I can find a Tm. Well, I have waited 2 times earlier. This time let me do it. I want the tension here. Let me change the color of the string. In the meantime, if you give me an answer, I'll be very happy. Treat this as one block, and treat this as another block. And those two are connected together by a massless string having tension Tm. And now let me draw it with this one. So I have 5 plus 1 having this P equal to 200 Newton, and I have 3 plus 1 joined by a massless string having tension Tm in it. And doing this question, Ansh Bhatia 6 kilogram and 4 joined by, yeah, yes, good. Ansh Bhatia, good. Mayank Gangwar, add 1 kg to upper. Very good, Mayank. Ansh Bhatia, I understood, Ansh. Very good. And solving this question, if you have understood today's class, then solving this question should be a cakewalk for you. As Isha Dhal suggested us before the class started, I asked her how could she get 100% in that quiz, which I thought that I have made a good quiz, but she got 100% in that quiz in the weekend course on activities. She said, I watched your video twice and I could get answer to every question correctly. If you have understood today's class, otherwise you watch the video again. If you have understood today's class, finding TM is no problem. So before we leave, let me modify this question so that you get a chance to practice something even more. This 5K, I need not draw the new diagram. I can, suppose you want to find out, in this string, you want to find out the tension here. This is 1/4. 1/4, 1/4 point. I am making 2 points at 1/4, 1/4. And I am naming, so I'll redraw the string here. Redraw the string here. Here it was a TH, here it is TL, and here it is TM. Now I'm saying find tension here and here. And I'm calling this as say T1, this as a T2. For those who have understood, there is no issue at all. You say them, tell them whichever point you want to tell them, they will be able to find it. But this question, I'm leaving it with you so that you practice it yourself. Well, if you want to ask something, if you want to discuss things, and you realize later on that you have a doubt, today we could not, there is no point of starting this pulley. So next class we will have completely on motion around a pulley. That there are, if you see, there are, I'll bring it closer. There are two masses on one side, one mass on the other, and then I have a pulley also, and we will move this pulley. We will move this pulley, and we will do those questions. Let it move, let it move. So we will do those questions of pulley, and you will find, if you have understood today's class, you will find that the next class will be a cakewalk, and you will be able to do any and every question of this type. So see you again on Thursday at 2 p.m. And in the meantime, if you want to get back to me, you want to talk something to me, and if you want to discuss something, you know where to do that. There is a Telegram group. The detail of the Telegram group is given in the beginning of that course which we are following. I need to work on that course. I need to redo that course because that course initially we had it NCRT based, but then I think the way we are doing it, that benefits you more for when if you are preparing for any entrance exams. So thank you so much. Thank you, Arnav Verma. Thank you so much, all those people who gave their time and watched it live. Because see, views are good. Views are good. Many people watch these videos, but those who come live and who talk and discuss, they are my real motivation. And I'm really thankful to those people. Vijalakshi, thank you. Rudra Chaudhary, thank you. Mudit sir, I have not been able to give the quiz. Yes, yes, yes. I have not blocked that quiz. You can do that. Quiz one, you mean to say in that weekend course? Yes, you can do that. Yeah, you can do that. And one class we will have it especially to discuss the quiz. If people find it interesting enough, we will have an extra class. So Ritik Bhatia, thank you. Aditya Kumar Singh, thank you. Rudra Chaudhary, thank you. Thank you, everyone. See you on Thursday at 2 p.m. Thank you.